science class. Let's go ahead and start with this homework. I got all the odd ones by the looks of it. It says 2 rovers are exploring the planet. The system of equations below show each rover's elevation, y, and the time is x. What conclusion can you reach about the system of equation? All right, sorry, I had to get a cough drop because my voice was just too scratchy. Here we see y equals 1.9x minus 8. Y is already have a 1 in front of it, so we're good with that one. But this equation doesn't have a 1y, it has 7y. So we're going to have to take it and do a little changing here. We got 7y. That equals, according to this, 13.3 minus 56. Since we need y to be 1, we're going to divide everything by 7. 7y divided by 7 is y. We have 13.3 divided by 7. We'll get the calculator out for that one. That's going to equal 1.9. I'm sorry, this has an x up after it, so should be an x here. And 56 divided by 7 would be a negative 8, right? Because that's a negative 56. And we might notice that we have the identical equation here. So the slope for the rover of the equation is, well, that's pretty easy, equal okay. The y-intercept of the equations are also equal. And the system equation has, well, if they're both equal, that means infinitely, infinitely, infinitely many solutions. What am I doing wrong with infinitely? There we go. Okay. Infinitely many solutions means these are the identical line. So they're going to give me the identical coordinates every time. Number 9 says, how many solutions does this system have? Once again, we got to rearrange everything. I'm going to start over here. Remember, we want everything to be in the form of y equals mx plus b. So let's go ahead and move this around. We're going to keep the 3y on this side. We're going to move this x over here, but remember, to get rid of a positive x, we have to subtract x from it. And whatever I subtract from one side, I subtract from the other. So that means on this side will be a negative x. And there's a 0 over here. I could put plus 0, but there's really no need to. So we have 3y equals negative x. Now I've got to get y by itself. So I'm going to have to divide everything by 3. 3y divided by 3 will give me y. Remember, there's a 1 in front of an x, so this is really going to be negative 1 over 3 x. Some of you could even write negative x over 3 if you wanted to. All right, now we're going to go ahead and try to solve this next one. It's already in the form of y equals x, so what we're going to do is divide everything by 12. And that way we'll get y by itself. 12y divided by 12 is y. And negative 4 divided by 12 will give me negative 4 over 12 x. We know we can take negative 4 and 12. 4 and 12 are both divisible by 4. So I'm going to divide my numerator and denominator by 1 in the form of 4 over 4. 4 divided by 4 is 1, so this is going to equal, well, negative 4 divided by 4 would be negative 1. And 12 divided by 4 would be 3. The x, nothing ever happened to it. And so the y came down. We have y equals negative 1 over 3x. And once again, we see these are identical. So how many solutions are there? I think we answered that in question number 7. Infinitely many solutions. And once again, I am having issues with the word infinitely. Infinitely. Okay. All right. Let's go to number 11. Determine whether the system of equation has one solution, no solutions, or infinitely many solutions. Okay. I could tell you right now it has one solution, and that's because the slopes are different. If I was to graph this, I know that one of my slopes is going to be a positive slope. This is a positive number, which means both of them have the y-intercept of 2. So that means they're both going to start at 2. But one of them is going to be going up 8 and over 1. And the other one's going to be going down 8 and over 1. And so that's going to give them one solution. So put over here one solution. Okay. And all that said was determine that, so don't need to do anything else. Number 13 is mine. Describe a situation that can be represented by using this system of equation. Inspect the system to determine the number of solutions and interpret the solution within the context of your situation. Okay, so we're going to describe a situation here. And you'll pardon me if I'm lazy. And I just want to go ahead and take the answer that is given, and instead of typing it all up, just pasting it right there. So in this example, Joe rents movies online for a $10 fee plus a $2 plus $2 per movie. All right, and Jim, and that's this one up here, right? We got a $10 fee plus $2 per movie. And the next one is Jim rents movies online for a $15 fee and a $1 per movie. Remember, there's always at least a 1 in front of our variable. Okay, there's one solution for these system of equations. All right, and that's 5 and 20. Let's figure out how they got 5 and 20. They got 5 and 20 because they were able to go ahead and use something called a substitution. So when I go ahead and solve problems like this, I can go ahead and subtract if I want. And because these are one away from each other, when I subtract, y is going to be minus y, that's 0. And x is going to be 2x minus x. That's going to leave me x. And then we have, I'm sorry, I got this mixed up. We're going to have to redo this here. Okay, as we were saying, we had to take 10 and minus 15. That's going to be a negative 5. Okay, now we have x minus 5. Remember, this is negative, so all these are now the opposite sign. This is a negative y, that's why it's 0. This is a negative x, that's why 2x minus x is x. And this is a negative 15, that's why we got a negative 5. Now I have to remember, we have a 0 over here, and we want to get x by itself. I'm going to rewrite this over here. And that means I need to get all the numbers to the opposite side. The only way to get rid of a negative 5 is a positive 5. Whatever I add to one side, I add to the other side. X comes down by itself, and we see that x is going to equal 5. Now we know x is 5. What we need to do now is substitute x in either one of these equations, 4, 5, and then we can find out what y is. So let's try the top one. We're going to say y is equal to 2 times x, and remember x is 5, so I'm going to multiply it to 5. And then we have plus 10. Well, 2 times 5 is 10, plus 10. And 10 plus 10 is 20, so y has to be 20. And now we see that when x is 5, y is 20. When x is 5, y is 20. I'm going to double check it by putting it in the other equation. To do this, I'm going to take y, and then I'm going to have it equal to x we said again was 5, and that's plus 15. And again, 5 plus 15 is going to be 20. And you see that this system works because whenever x is 5, y will be 20. All right, let's move to number 15. All right, this says the equation represents the height, which is y, of flowers in inches after x days. So y is the height and x is the days. So the number of days multiplied to this plus 2 will give me the height of flowers. The number of days times 0.4 plus 2 will give me the height of this flower. What does the y-intercept of each equation represent? Remember, the y-intercept is representing the starting point. So if both of these are 2, and we're talking, it doesn't really say inches or anything, does it? Let's see. Oh, inches, good. Then that means this is height in inches. So both of these start at 2 inches because they're both positive 2 at the end. This is going to be 0.7, so it's going to go and have a slope that is going up 0.7, right, and over 1. This one is 0.4, so that slope is not going to be as big, but it's still going to go through 0.2. So will the flowers ever be the same size? Sure, when you first plant them. Yes, when they were first planted, they were the same height. All right, let's go to number 17. Under what circumstance does a system of equations qx plus ry equals s and y equals ts plus s have infinitely many solutions? Wow, okay. Let's rewrite these. Remember, we want these in y equals mx plus b form. So this first one here, I'm going to give myself some room here. I'm just going to write it out. Qx plus ry equals s. We want to get y by itself, so we're going to have to subtract qx from this side. which means we have to subtract QX from this side. Now let's rewrite everything. This is going to be RY equals negative QX plus S. All right. Now let's rewrite this other one. What's already in the form of Y equals TX plus S. Well, S is already the same. We don't know what S is, but we know that S is representing it as a variable. So if it's 5 here, it's going to be 5 here. So we know they're the same. To have infinitely many solutions, they have to be equal to each other. So I'm going to say, first of all, when negative Q is equal to T, and let's see, R is equal to 1. Remember, there's a 1 in front here. R equals 1. So when that happens, these will have infinitely many solutions. All right, that's all the ones I was doing. So you have the rest. See you in class to check them, and have a great night.